Hi guys, so for our project, we're doing the Kaggle competition for an Instacart market basket analysis. Our main focus is to predict whether an item will be reordered based on various attributes in the dataset provided. What we've done so far is some preliminary data exploration and visualizing the dataset with the use of a couple plots. I'll go over our notebook where we've made these plots, and then Helin will talk about the plans for the data in terms of machine learning algorithms and our next steps. So here you can see is where I'm loading the data set. The data set is pretty big, so it takes around 2 minutes to make the data frames. After that, I just look to see what the various attributes of each of the data frames are. And then here, I'm calculating the number of null values in the orders data frame. Next, I created a plot to see the frequency of each of the prior, train, and test data sets. These were given, but if we feel like we need to adjust the train test split, we will do so. After that, I created these two plots to show order frequency based on hour of day and day of week. As you can see, most of the orders tend to happen in the morning and early afternoon and on Sunday and Monday, which makes sense since these are at the beginning of the week. These are the beginning of the week. Next, I plotted the order frequency based on hour of the day for each day of the week. Sunday had a peak around 1 p.m., while Mondays was at 10 a.m., and the rest of the days followed a similar trend of having peaks in midday. Here's a heat map comparing order frequency of day of week versus the hour of day. Here's a better view of it. As you can see, the highest correlation is found on Sunday afternoon and on Monday morning. Lastly, I made a plot of frequency distribution of days since prior orders, so basically reorders. There are large peaks at 7 days and 30 days, which follows normal patterns of reordering weekly or monthly, with smaller peaks at 14, 21, and 28 days. I calculated the percent of products reordered from prior and trained data sets and got 59 and 60% respectively. Now I'll hand it over to Helin.
Uh, as Nehal has showed you, our dataset has several CSV files to contain the dataset. Like actually 6 or 7 of them you can see from the variables, else, departments, other products pre-order, other product string, orders, and product. The first thing we will do is to lottery each dataset. As you can see, the L contains LID, which is categorical data. The department has department ID, which is also categorical. The other products prior, including the order ID and product ID, and it's add to cart order, ordered, and the other product string is similar to the other products prior. And we have all the others contains most information, and the product which contains the LID and department ID. And for each product has a same order, has a same LID and department ID. It may not be unique, but the products must be very similar. For example, ketchup from brand A and ketchup from brand B have a same LID and department ID, but different product ID. But when we are going to use it for prediction, we are going to treat it as the same. So we are only going to use the LID and department ID. So then what we need to do is to merge the data frames. Then the first thing we did is based on the order ID and product ID, which we use as the case in data sets in relational database, we merge all the data sets into our data frame with 12 columns. Then we drop the features we don't want to use in our decision tree, which is the order ID, product ID, user ID, and evaluation side. These are either too unique. For example, each line has a different order ID, and there are almost a million of products. And then we drop the train data, the Y data side of the data frame here. Like it only contains reordered, is whether either 1 or 0. If it's 1, it means the user has made an order before and he will reorder it. If it's 0, it means not. And the last is the training features we are going to use for the decision tree. All the data here all the data here, how do I say it? Sorry. All the data here are not continuous and they are categorical data. That's why we are not going to normalize it or standardize it. It will be meaningless. And we are going to use decision tree based on this info. Like either it has a LID of smaller number or greater number, things like that. Yeah, thank you.